Welcome to our comprehensive tutorial on Prisma, the modern database toolkit for Node.js and TypeScript. This is Sakura Dev Channel, and in this tutorial, you'll learn how to use Prisma to quickly and easily connect to your database, define your data model, and perform powerful queries using a simple and intuitive API. We'll start by showing you how to set up Prisma in your Next.js project, although you can use this tutorial on any other Node.js framework like Express or Nest.js. And then we'll walk you through the process of defining your data model using Prisma schema language. And you will also learn how to implement one-to-one, one-to-many, and many-to-many relationships between your models with Prisma schema. Next, we'll dive into Prisma's powerful query API, which allows you to fetch and manipulate your data with ease. And finally, we'll show you some advanced features of Prisma, such as migrations and introspections. We also talk about offset pagination, cursor pagination, relation filters, operators, and transactions. So whether you're a seasoned developer or just getting started with Node.js and databases, this tutorial will provide you with everything you need to know to master Prisma. So let's get into it. Okay, I open up a Next.js project, and the first thing we should do here is to set up our database. We are going to use Postgres database here, and in my opinion, the most convenient way of setting up a database in our machine is to use Docker. So you should have Docker installed on your machine. And since this is not a Docker tutorial, I have already created a docker-compose.yaml file, and let's see quickly what's going on in this file. We have two services, a Postgres service and also a adminer service. So Postgres is our Postgres database, and adminer is just a simple graphical user interface to see what's going on in our database. So as you can see, we have set the volumes and also the ports. The default port of the Postgres database is 5432. And then we set the name of our database to testDB, the DB user to Postgres, and also its password to just Postgres. That's simple. If you're not familiar with the Docker and Docker Compose, just copy this file into your project, and in order to run this Docker Compose file, you can type in your terminal Docker Compose up, or the easy way is to install the Docker extension on your VS Code and just right-click on the Docker Compose file and click on the Compose app. As you can see, our two containers are started, and if I go to our browser and go to the localhost 8080, which is the port of the adminer, and select the Postgres here and set the username to Postgres and also password to the Postgres, and click on the login, you can see we have a testDB here. So in this way, we can easily set up the Postgres database and also the adminer with Docker Compose. So now we can go ahead and set up the Prisma in our project. And in order to do that, we have to install two packages. So here I go to the terminal and install the Prisma, npm install prisma --save dev. Okay, and then we need to install the Prisma client. So I'm going to say npm install at prisma/client. So note that the Prisma itself, it's a dev dependency, but the Prisma/client, it's not a dev dependency. Okay, and then we need to initialize a Prisma schema here. So I'm going to say npx prisma init. And here, as you can see, it creates a Prisma directory, and inside it we have schema.prisma file. And here, as you can see, we have a generator client, which its provider set to Prisma client.js, which means that we are going to use Prisma client of JavaScript in order to access to the Prisma. And also we have a data source, which determines the type of our database and also how to connect to it. And here, as you can see, the provider is set to PostgreSQL by default, but we can also have MySQL, SQLite, SQL Server, and also MongoDB. And then we have the URL, and it means that inside the env file of our project, look for the database URL variable. So I go to the env file, and here I've already created a database URL and set it to Postgres Server. So it starts with the PostgreSQL, just like a URL, and then colon / then the user of our PostgreSQL, which if I go to the Docker Compose file, you can see the Postgres user is set to the Postgres, and here inside the database URL environmental variable, I replace the user with the Postgres, and also pass is Postgres. Our server is on the localhost 5432. You remember here we map the port number 5432 of our machine into the same port inside our Postgres container. So let me go back to env file, and then we have the DB name, which is testDB in our case. So I put the name of our DB inside the Postgres and just leave the schema to public. Okay, now we are ready to connect the Prisma to the Postgres database. But before doing that, we need to define our data models inside the schema.prisma file. So what is a data model? Actually, it represents an entity in our database, which means that the data models will be mapped to the tables inside our relational database like Postgres or collections inside the MongoDB. And in order to define the data models inside the Prisma, we have two options: introspection and migration. With introspection, we already have a database, and inside our database, we already defined our tables. And we are going to create the data models based on the tables inside our database. So our database will be the single source of truth here. But in the migration, we don't have a database in advance. We create our data models manually, and then we run a migration, and our tables inside our database will be created based on the data models in the schema.prisma file. This tutorial will be on migration system, but before moving forward, let me quickly give you a simple example of introspection. So if I go back to the adminer, you can see we have a testDB here, and inside it, let's quickly create a table named user. And in the columns, we have ID, which is going to be an integer. And also we have a name here, which is going to be type of text here. And let's keep it simple. So our table just have an ID and name. So let's save this. And you can see we have a table here, which has an ID and also a name column. So let's go back to our VS Code. And here, in order to create our data models based on the table inside our database, we use dbpool command. So as you can see, our schema file doesn't have any data model here. So here in the terminal, I'm going to say npx prisma and then dbpool. And here we go. As you can see, it automatically created a user model for us, which has an ID and also name inside it. So in this way, we can create our models based on the tables inside our database. The other option to create our model is migration. So in migration, we manually create our model, and then we run a migration to create the table based on the data model inside our schema file. So which one is better? If you have a database in advance, go for an introspection. And if you don't have a database in advance, go for migration. And in this tutorial, we are going to use migration approach. So let's remove this data model here and also close the terminal. And now we are ready to move forward to the next section. In this section, we're going to define the data models inside this diagram. You can find this diagram in the Prisma documentation. So let me quickly explain what this diagram is. It has a user model, and these are the fields of the users. So it has an ID, email, name, and role. And then each user has a profile. And also each user can have multiple posts. And each post can have multiple categories. And each category can belong to multiple posts. So don't worry if you didn't understand the relationships between these models. I will explain them and also create them in action along the way. So let's get started. So I go back to our VS Code, and here inside the schema.prisma file, we're going to define our first model. So in order to define a model, we use the model keyword and then the name of the model. So in this case, it would be user. And then inside it, we can define the fields of the user. So As you can see here, it has an ID, email, name, and role. So here the first field is ID and its type is int. And note that here we don't use the TypeScript types here. Instead, we have to use Prisma type. So don't confuse these types with the TypeScript types. The second field is email and its type is string. And again, note that the types of the Prisma start with a capital letter. And then we have name, which is going to be a string as well. And also we have role inside the user that for now, let's set its type to string. So Prisma gives us an error, and that's because every model in the Prisma must have a ID field. Of course, we have defined an ID field here, but we didn't tell Prisma explicitly that this ID should be the ID or primary key of the user model. So in order to set this ID field to be ID of this model, we use the @ID attribute. So you say @ID here, and you can see the error is gone. So this @ID is an attribute in Prisma. With attributes, we can modify the behavior of the fields or models. And also we have other attributes that I will explain them along the way. For example, we can have @unique attribute, which set this email field to be unique among all users. So in this way, we tell Prisma that each user must have a unique email. Okay, let's save this and open up a new terminal. And inside it, we are going to run a migration, and this migration will create a user table inside our database. So here, in order to run a migration, I'm going to say npx prisma migrate div, and then we should set the name of the migration. I'm going to say --name, and then set it to init. So if I run it, it says that there is a user table inside our database. And if we run this migration, all data will be lost. And that's because in the previous section, we have created a user table manually in our database. So I hit yes here to run the migration. And let's go to the adminer to see if the changes to the testDB have been applied. So here you can see we have a user table here. And inside it, we have a ID, email, name, and role. And then we have a primary key, which is the ID, and then a unique field, which is email of the user. So yeah, with the migration, we can commit the changes of our Prisma schema into our database. So let's go back to our VS Code, and here you can see we have used some attributes to modify the behavior of our field. We can also modify the behavior of the model itself with the model attributes. So after our last field, we can use the model attributes. So model attributes must have two @signs. So @sign, for example, map, which can change the name of the table inside our database. So for example, let's set the name of this user table to users. So let's save this and run the Prisma migration again. And if I go back to the adminer and refresh, you can see now we have a users table instead of the user. So if I click on this, you can see that the table is the same, but its name has changed. And also we can change the name of the field inside our table. So here, for example, we can have @map, and inside it, we set the name of this field in the table of database. For example, we can set it to first name, and let's save this, run a migration again, go back to adminer, refresh the page, and you can see the name of the field has changed to first name. So the map attribute can set the name of a field or a model inside our database. And the next attribute that I want to show you is the default attribute. With default attribute, we can set a default value for our fields. So here in the ID field, we can set it to auto increment. So in this way, every time we want to add a user into our table, we don't need to provide an ID for it. It will be automatically created by the auto increment function because we set its default value to the auto increment function. So let's save this and run our migration again, instead of adminer, we can use a tool named Prisma Studio. So in order to use it, I'm going to say npx Prisma Studio. So as you can see, the Prisma Studio is running on the port 5555. So I go back to browser and say localhost 5555. And here you can see that the Prisma Studio is running. So if I click on the user model, we can add a user here inside our user table. So here you can see that the ID is set to auto increment. So we can have an email, for example, some@somewhere.com, and the name is John, and also its role is user. And here we can save the changes, and you can see the ID is automatically set to 1 because of the auto increment function. So with the default attribute, we can set a default value for a field. We can also set the ID of our model with a combination of multiple fields. So for example, let's remove this ID attribute from the ID, and here we can use $ID, and inside it we can specify the fields that we want to make the key or ID of the user. So for example, we want to add the email and also the name of the user. So now the ID of this model will be a combination of email and name. And we can do this with the unique attribute. For example, we can make the combination of the email and name to be unique. Of course, when we specify these two fields inside the ID attributes, the combination of these two fields automatically will be unique. And also we can have a unique combination of multiple fields. For example, we can specify $unique here, and inside it we can specify the name and role. So the combination of the name and role will have to be unique inside the user table in our database. And the other model attributes that I want to show you is the $index. And with this attribute, we can define an index for this model. For example, we can set it to ID, or we can have a multi-column index, for example, ID and email. So in this way, we can define an index for our model. And the last thing I want to tell you in this subsection is that if we want to allow null values for a field, we can have a question mark after the type of the field. So in this way, the role field can have null value. Okay, now we can move on to the next section. Okay, in this section, we're going to talk about enums in Prisma. So here, as you can see, the user has a role field, which its type is set to string. But user role can only take two values, user and admin. So instead of setting its type to string, we can define an enum for the user role. And the concept is just like the enums in TypeScript. So in order to define an enum in our schema, we use enum keyword and then name of our enum. So I'm going to put a role here. And then inside it, we put the specific values that the role enum can take. So we have the user and also admin. So note that here we don't use comma in order to separate the values inside the enum. Okay, and now we go to the user role here and change its type from string to the role enum that we just defined. And set a question mark here in order to make it optional. And then we can define a default value for this role. So I use the @default, and inside it we put the user. So note that here, if we put a value other than these two values here, we get an error by the Prisma. So for example, let's say user2, and you can see that we got an error here. So let's change it back to user, and in this way we can define and use a enum in Prisma schema. Okay, in this section, we're going to talk about relationships between the models. So we're going to explain and create one-to-one, one-to-many, and many-to-many relationships between the models. So let's get into it. Okay, we go back to the diagram of the Prisma documentation. And here, as you can see, we have a one-to-one relationship between the user and profile. So what does that mean? It means that every user can only have one profile, or better to say, every user at most can have one profile, which means that a user can have 0 profile or just 1 profile. But each profile must always be connected to one user. And if you look at the profile model, you can see that it has an ID, bio, and also a user ID that is FK. So FK stands for foreign key. So when we look at the profile record, we can easily determine that to which user it belongs because we have the user ID inside the profile. So I hope that makes sense, and let's go back to our Prisma schema and create this relationship in action. First of all, we need to define profile model. So I'm going to say model profile, and inside it we're going to have an ID which its type is int, and let's mark it with the ID attribute and also default, and inside the default let's call the auto increment function. And also it has a bio which is going to be string, and then it is going to have an user ID which is going to be int, and let's mark it with the unique attribute. And in order to define our relationship, we're going to have a user which its type is the user. So this user will refer to the user model. And then we are going to mark it with the @relation, and inside it we're going to have a fields, and inside the fields we are going to specify the user ID here, and then we have a reference, and here we have to specify the fields inside the user model that this user ID will point to. So I'm going to say user ID will point to the ID of the user. So as you can see, the relation attribute gives us an error, and that's because when we are going to reference to this ID inside the user model, it must be unique. So we can mark it with @unique or just @ID. And it gives us an error again, and that's because inside one model we can't have @ID attribute and also double @ID at the same time. So if I remove this double @ID, it will be fixed. But here the relation attribute gives us another error, and that's because we have to have a profile field here inside the user model with type of profile model. So let's define it. I'm going to say profile and set its type to profile model, and we have to make it optional with the question mark. Here, as you can see, the errors are gone, and now we have a one-to-one relationship between the user and profile. So a user can have 0 or just 1 profile, and each profile is always connected to just one user with this relation attribute and user ID that we have defined inside the profile. So in this way, we can have a one-to-one relationship. And one thing I should mention here is that on one-to-one relationships, deciding on which side should have the relation attribute inside it is on you. So here we have decided to put the relation attribute in the profile model, and we can easily move the relation attribute to the user model. So in order to do that, we need to remove this user ID here. So I comment it out and remove this relation from the user, and then it should have be optional. And then I go to the user model, and before the profile, we're going to have a profile ID and set its type to int, and it is going to be optional here, and then put the relation attribute on profile field. So here we can say @relation and set the fields of our foreign key, which is profile ID, and it will refer on ID inside the profile. And in order to get rid of this error, since the profile ID is optional, the profile field itself must be optional as well. And also this profile ID must be unique. So in this way, we move the relation attribute from the profile to the user. And as I said, deciding on which side should have it is up to you. Okay, and the last thing I can mention here is that you can have multi-field relations between your models. So in order to do that, let's comment the user model and also the profile model. So let's quickly create a dummy user model here. So I'm going to say model user. It is going to have a first name, which is going to be string, and also it is going to have a last name that is going to be string as well. And let's say these two fields, first name and last name, are the primary key of the user model together. So let's define them in the double ID attribute. Then inside it, we specify the first name and also the last name. Okay, and now let's create a dummy profile model. Profile, Okay, and let's say it has an ID inside it, which is going to be int, and let's mark it with the ID. And let's say we decide to put the relation attribute inside the profile. So here, since the primary key of the user model is first name and last name, inside the profile model, we should have both of them as a foreign key inside the profile model. So here, I'm going to define a user first name, which is going to be string, and also a user last name, which is going to be string as well. And then make the combination of these two, user first name and user last name, unique. So here I use @ unique, and inside it we're going to specify the user first name and user last name. And then we can have a user field, which its type is going to be type of the user profile. And then we can have the @relation attribute. Inside it, first of all, we need to specify the foreign key fields, which is going to be user first name and also user last name together. And then these two will refer on the first name and also last name of the user model. And then we are going to have a profile field here, which its type is going to be profile and it will be optional. So in this way, when we have a multi-field primary key here, we can have a multi-field relationship between our models. Okay, let's comment out these two models so we can have it inside the GitHub repo. And let's uncomment our main user and profile. Okay, now we can move on to the next subsection, which is about one-to-many relationships. So again, I go back to the diagram of the Prisma documentation, and here we can see we have a one-to-many relationship. So 1-n means one-to-many relationship. So what does that mean? It means that each user can have multiple posts. So a user can have 0 or multiple posts. And if we look at the post model, you can see it has an author ID inside it, which points to the ID of the user. So when we look at a record of the post model with the field of author ID, we can determine to which user it belongs. So let's create this relationship in action. So let's go back to the Prisma schema. And first of all, here, let's define the post model. So I'm going to say model post. And inside it, we're going to have an ID, which its type is int. Let's mark it with the ID and also at default auto increment. And then we're going to have a author ID, which is going to be int. And then we're going to have a title, which is going to be string. And then we're going to have a created at, which is going to be type of datetime, and set its default value the now function. So when we are going to insert a post record, we don't need to provide the created at value. It is automatically set to the time that it is being inserted. Okay, and then we have the updated at, and its type again is going to be datetime, and let's mark it with the updated at. So whenever we update a record of the post model, this field will be updated with the time that it is being updated. Okay, and then we're going to define a published field for it, which is going to be a boolean, and let's set its default value to false. Okay, so as I said, each post must belong to one user. So we have the author ID here, which refers to the ID of the user. So here we can define a author and set its type to user model, and then we have a relation attribute, and then inside it we're going to define our fields, which will be our foreign key. It is the author ID of the post, and then it refer to the ID of the user. So again, it gives us an error, and that's because we have to go inside the user model and define a post field. So each user can have 0 or multiple fields. So I'm going to say posts and then set its type to post profile, which is going to be a list of them. So each user can have multiple posts. And if I scroll down to the post model, you can see that the error of the relation is gone. So in this way, we can define a one-to-many relationship between the user and post model. So again, inside the user model, we have defined a field and set its type to a list of posts. So it means that a user can have a list of posts. And then inside the post model, we have defined an author ID here. So let's move it to the side of author. We have an author ID, and then we have an author field, which its type is set to user, and we mark it with the relation attribute, and inside it we have determined that the user ID profile will refer to the ID of the user. And that's it. We have defined a one-to-many relationship between user model and post model. Okay, now we can move on to the next subsection, which is about many-to-many relationships. So what is a many-to-many relationship? Well, according to the Prisma documentation, it refers to a relation where 0 or more records on one side of the relation can be connected to one or more records on the other side. Let's say we have two categories, big data and also data science. So a post can belong to these two categories at the same time. And also a category, for example, big data, can belong to many other posts. So in order to implement this type of relations, we have to create a pivot table, and then we have to set up two one-to-many relationships between the post and the pivot table, and also between the category and pivot table. So in this way, we can implement a many-to-many relationship in relational databases. In the Prisma, we can set up this type of relationships in two ways, explicit and implicit. In the explicit way, we have to create a model for this pivot table in our schema. But in the implicit way, we don't need to create a model for this pivot table. And also, we don't need to create this type of relationships between the models and the pivot table. It is done and managed by Prisma implicitly. So the implicit way is much more easier. But one of the advantages that explicit way has is that we can have more fields inside our pivot table. So when we need additional information about our relationship, we can go for a explicit way. So in order to create a explicit relationship, we have to create a model and then set up two one-to-many relationship between the first model to the pivot table and also between the second model in the pivot table. So since we have seen how to create a model and also create one-to-many relationship in this tutorial before, in this section, we just go for a implicit way. So in order to do that, we go to our schema file, and here let's quickly create the category model. And inside this category, we have an ID, which its type is int, and let's mark it with the ID attribute and set its default value to auto increment, and also it has a name, which is a string. Okay, now in order to create a many-to-many relationship, first we need to add a post list here. So inside the category, we set posts and then set its type to a list of post model. And then inside the post model, we're going to have a categories and then set its type to a list of category model. And that's it. We don't need to use relation attributes in order to set up this type of relationship implicitly. And note that here, inside our database, a pivot table will be created by the Prisma, but we don't have it inside our schema file. Okay, I think that's it for this subsection. And now we can move forward to the next section. And before moving to the next section, if you're still with me until this point of the video, please hit the like button. That will encourage me to move forward. And if you subscribe to my channel, that would be icing on the cake. Thanks for your support. Okay, in this section, we're going to take a deep look at how we can use Prisma Client in order to do some basic and also advanced CRUD operations. So to start with, first of all, we need to run a migration. So in order to do that, I'm going to say npx migrate dev --name and then the name of our migration. So I'm going to say final here for the name of the migration, and let's run it. And okay, it is done. So in the next step, we need to install the Prisma client. So we have installed it in the first section of this video, but if you don't have installed it yet, we can use npm i @prisma/client. Okay. And in order to do a CRUD operation with Prisma client, first we need to instantiate a new Prisma client for each of our operations. But this is not a good idea. We need to create a global instance of Prisma client, and whenever we needed to do a CRUD operation, we can use that global Prisma client instance. So in order to do that, here inside the source directory and the lib directory, I'm going to create a file called prisma.ts. And then inside it, I'm going to paste these 5 lines of code, which create a global instance of Prisma client, and then export default this global Prisma client from this file. You can find this file inside the lib directory in the GitHub repo of this tutorial. So you can easily use it inside your application. So let's save this and close it. Also package.json. Let's close terminal as well. And now I go to the API directory inside the app directory. And here let's create our first API that is going to use Prisma client. So for example, let's say we want to create a get API that retrieves all posts. So here I'm going to create a directory called post. Then inside it, I'm going to create a wrap.ts file. Okay, then inside it, I'm going to export a function, async function get, and here we can say const posts equals to await Prisma, which is our global Prisma instance that comes from the Prisma file inside the lib directory here. Okay, let's go back to our API route, and here I'm going to say await Prisma.post and then find many. So find many is a function that returns a list of posts here. If we don't provide any argument here, it just returns all of our posts. So here we can return a response, return new response. Then inside it, we're going to say JSON.stringify posts. Okay, let's save this and run our server, npm run dev. Okay, now we can test this API with Postman or Insomnia client. I use Insomnia. So here you can see we have a GET request to the localhost port 3000, which is our Next.js application, and then /API and then /post. So let's send this GET request to this API. And here we have an empty list, and that's because we don't have any data inside our database. So in order to test the Prisma and our database, we need to populate our database with fake data, which is called seeding the database. And we can do it with Prisma. So let me show you what I mean in action. So I go back to our VS Code, and inside the Prisma directory, I'm going to create a file named seed.ts. And inside it, I'm going to paste a piece of code that will insert some sample data in our database. And since so far we haven't talked about how we can create or insert data in our database with Prisma clients, just don't worry about this piece of code. Later in this video, I will explain how we can insert data with Prisma client in a great details. And for now, just keep in mind that here we create a Prisma client, and then we create a list of data that we are going to insert in our database, some users with their post, and then here we have a async function main, and inside it we loop through that list of data and then insert them with the create function into our database one by one. And here, when running the main function is complete, we just disconnect the connection of the Prisma client from our physical database. So in this file, we just added a piece of code that will insert some data into our database with Prisma client. Okay, and then I go to the package.json file, and here at the end of this file, I will add a key here, Prisma. And then inside it, we add another key called seed, and then set its value to TS node prisma/seed.ts, which is the path of the seed file. So let's save this and open up our terminal. And now we can run our seeding process with this command. npx prisma db seed. Okay, we got an error here, and that's because the TS node is not installed in our project. So let me quickly install it. npm I ts-node. Okay, now let's run the npx prisma db seed again, and we got an error here again. And let me see, what is that? Okay, since we are using Next.js here, we need to add some configuration to this TS node script. But if we are using Express.js or Nest.js, this TS node script will work properly. But since we are using Next.js, we need to add some configuration here that I found in the documentation of the Prisma. So let's replace this script with that, just add some compiler options, and let's save this and run the db seed again. Okay, and you can see here that it created 3 users for us in our database. So since we are using Next.js, we needed to add some compiler options in the TS Node script. So yeah, in this way, we can seed our database for testing purposes with Prisma client. Okay, now let me go to the Prisma Studio. So I'm going to say npx Prisma Studio. And here you can see we have inserted users in our database. So let's go to the post table, and you can see we have the post of the user inside the post table. So let's go back to our VS Code, and here let's run our server. And now let's go to Insomnia client to test the post API. So if I click on the send, okay, it returns a response that will contain all the posts inside our database. So let's go back to our post API. Here you can see we have the get function, and inside it we use the Prisma client.post.findMany. And since we didn't provide any argument inside this findMany function, it just returns all the posts inside our database. So yeah, in this way we can run a simple query with the Prisma client. Okay, and before moving to the next section, which is about how we can narrow down the result of a query with filters, you need to know that we have other functions for retrieving the data from our database. FindMany function will return a list of our data entities from our database. The other function is the find first that will return the first record in its table from our database. For example, post.findFirst will return the first post in the post table. So let's save this and run our API again. You can see it returns the first post from the post table. Okay, and the other function is find first or throw. It just returns the first post if any post is existed in our database, but if it doesn't find any post in our database, it will return a not found error. And the other function is find unique, that in which we need to provide a filter for it with a unique attribute. So in the next section, I will talk about the filters. And the last function is find unique or throw. It just works as the previous one, but if it doesn't find a record in our database, it throws a not found error. Okay, now we are ready to go to the next section, which is about how we can use filters. In this section, we're going to talk about filters, how we can narrow down the result of a query based on some criteria. Okay, let me create an API route for the users. So here inside the API directory, I'm going to create a directory called user, and then inside it, I'm going to create a route.ts. Okay, now let me copy the code from the post route, and then here let's paste them inside the user route. So here we have a get function, and let me remove that, and here we have const users equals to await Prisma.user.findMany, and then inside it I'm going to pass an object, and inside this object we're going to specify the where object, and inside this where object we can specify our filters. For example, let's say we want to retrieve all users that their name is John. So here we specify name and set it to John, and let's change this post to users. So let's save this and go to our Insomnia clients, and here you can see we have created a user get request that calls this API, our localhost 3000/API/user, the route that we just have created. So let's send this get request to our server, and you can see it returns us a list that contains a user object that its name is John. So let's go back to our VS Code and, for example, set the name to Sarah, and let's save this, send the request again, and you can see that this time the return list contains a user object with the ID of 4 and the name of Sarah. Okay, cool. Now let's go back to our VS Code, and here we can also set this name property to an object, and inside it we can specify operators for our name property. For example, we can specify a start with and then we can set it to J. And now each user that its name starts with J will be retrieved from our database. So let's save this and go back to our Insomnia client and send the request, and now the response is a list of 2 user objects that their name start with J. And also we can have end with, so here we can say end with, and let's set it to N, and let's save this and send the request again. And here we can see that we have 2 user objects that both their name end with N. And for example, we can specify contains here. So let's specify contains and set it to A. Let's save this and send the request again. And now we can see that the both user objects have the A letter inside their name, Jack and Sarah. And let's make it a little complicated. So we can say that the name must contains A and also start with S. So let's save this and send the request again. You can see that the Sarah is start with S and also it has A inside. And also we can have other operator here. For example, GT, which stands for greater than, which works with numerical value, GT, which stands for greater or equal than a numerical value. We can have in, for example, let's say we want a user that its ID is among a list of IDs. So we can specify in operator, and then, for example, we can say 1 and 2. So every user that its ID is in this list will retrieve from the database. So let's go back to our Insomnia and send the request again. You can see that the user with ID of 1 and also ID of 2 are retrieved from the database. And the other operator that we can specify here is not in. Okay, now it retrieves all user that its ID is not in this list. So let's send the request again, and here we can see that the user with the ID 3 and 4 are retrieved this time. Okay, we can do this with the not operator here, just like this. We can set it to not, and then we can set it to an object, and here we can say in again and set it to the list of 1 and 2. It's just like the previous one. So let's send it, and you can see the same result is returned from the response of the API. Okay, and here, for example, let's say the ID is not greater than, for example, 4. It retrieve all user with their ID is not greater than 4. So let's send the request. You can see the ID 1, 2, 3, 4 was retrieved. Let's set it to, for example, 2. Save this again. You can see the ID of 1 and 2 was retrieved in database. And you can see that we can specify different operator inside our filters. And let me show you another scenario. For example, we want a user that its ID is not greater than 2, or the name of the user start with the S. So to do that, we can use the OR operator. So we can set the where object to an OR operator, and then this OR is set to an array, and then inside the array we can specify an object, and let's copy this ID object to the first object inside the OR list, and then we can create the other filters inside another object inside the OR list. So here we can say the name starts with letter S. So let's go to Insomnia and send the request. You can see that it will return a list of user object which the ID of the user is not greater than 2. So these two will be the result of the first filter, and or the name of the user start with the S, which is the result of the second filter inside the OR list. Okay, and we can also have the and also not list inside the where object. So for example, let's say we want to retrieve all posts that their title contains GitHub or Twitter inside it, and its publish is set to true. So let's go to the post API, and here let's say post.find many, and inside it we're going to pass the where object. And first let's specify the or list here, set it to a list, and inside it we can have the title, which is an object, and inside it we specify the contains and set it to GitHub, and also we set another object for the or list, and again set the title here, contains Twitter. And now let's define our and object here. So after the or list we can have a and. So note that here and must be an object, not a list. So inside the and object we can specify the published and set it to true. Okay, so this query will retrieve all posts that the title of the post contains GitHub or Twitter, and also their publish is true. So let's go back to our Insomnia and send the request to the post API. You can see that it returns a post object here that the title has the Twitter inside it, and also the publish is set to true, but it didn't retrieve the post with the GitHub inside its title. So let's go to the Prisma Studio, and here let's make the title a little wider, and you can see the post with the GitHub inside the title, and also the publish is true. So let's go back to our query, and here let's change the H of the GitHub to a uppercase and save this, send the request again, and yeah, you can see that now we have two objects, that the title contains Twitter or Prisma and the publish is set to true. So in this way we can combine the or list with the and object. Okay, you just saw that the filters are case sensitive, so we can have a mode object here inside the title and set it to insensitive. Okay, and let's change the GitHub to the lowercase, and let's change it here. So you can see the GitHub is all lowercase. Okay, let's save this and send the request again, and you can see that the response is the same. We have the post with the ID of 3 that has the GitHub inside its title, but the G and H here is uppercase, which is different with the GitHub that we provided here. So this mode insensitive makes the filters insensitive to lowercase and uppercase letters. And here we should note that this mode only works on Postgres and MongoDB connectors. Okay, now we can move to the next section, which is about relation filters. So what is a relation filter? In Prisma, a relation filter is used to filter data based on the relationships between tables in a database. With one to many and many to many relationships, we can use 3 relation filters: every, some, and none. So let's explain each of these 3 relation filters with an example. So let's say that we want to return a list of users, that each user inside the result set must meet the following criteria. All posts of the user is published. So let's go to the user route here and let's comment this out. Okay, now we can write our query with the relation filters. So here I'm going to say const users equals to await prisma that users that find many. So we want to find a list of user based on a relation filter. So inside the find many, we provide an object which has the where object inside it. So inside the where object, we can say that we want to put our relation filters on the post table. So here we just specify the posts and then set it to an object, and inside the object we can have one of the 3 relation filters: some, every, and none. So here we want to find all user, that each user inside the result set, all its posts have been published. So here, since the condition says all its post is published, we use the every filter. So inside the every, we can now define our condition on the post model. So here we say published is true. Okay, so now let's go to Insomnia and send a request to the user route. As you can see here, the result set returns 3 users. The user with the ID 1, 2, and 3. So now let's go to the Prisma Studio, and here inside the post model, you can see that the user 1 just has 1 post, and that post is published. It is the same with the user 2 and 3. all of them just have one post that it's published is set to true. But the user 4 has two posts. One of them, the published, is set to true, and one of them is set to false. So this user number 4 didn't show up in the result set of our query because it violates the criteria that says all posts of the user must be published. Okay, let's go back to our Insomnia, and you can see that the user 4 didn't show up in the result set of the query. So now let's change our example. Let's say we want to find every user, that each user inside the result set must meet the following criteria. At least one of its posts is published. So here inside our query, we can just change the every relation filter to the sum. So here we are saying that we want to find every user, that each user inside the result set in some of its posts published is set to true. So let's save this and go back to our Insomnia. Let's send our request, and now you can see that the user number 4 is also included in the result set of the query. And that's because in some of the posts of the user number 4, which is this one, the publish is set to true. So let me change the criteria. Let's say that we want to find every user, that each user inside the result set must have at least one unpublished post. So here we can say that some of the post of the user has a post with published set to false. So let's save this and now run the query, and you can see only user number 4 is included in our result set. And that's because all the other 3 just have one post and their published is set to true. But user number 4 at least have one post with the published is set to false. So let's change our criteria a little bit. Let's say we want to find every user, with each user inside the result set meet the following criteria. None of its posts must be unpublished. So first of all, we replace the sum with the null relation filter. Okay, so here actually we are saying that find every user with none of its posts, the published is set to false. So let's save this and go to Insomnia, run the query, and you can see the user number 1, 2, and 3 are included in the result set, and that's because all of them, 2, 3, and 1, doesn't have any unpublished posts. Okay, so that's it for the one-to-many and many-to-many relation filters. And also there are 2 relation filter which works with the many-to-one and one-to-one relationships, which are is and is not. So let's say that we want all posts with the name of their author is, for example, Jack. Okay, so the relationship between the post and the user is many to one. Many posts can have one user. Okay, so let's go back to our VS Code and let's go to the post route. And here let's just comment out this query and let's create a new one. So here we can say const posts equals to wait prisma dot post dot find many, and then provide the where object, and inside the where object we want to put the relation filter on the author. So here we say author and then set it to an object, and inside the object we can specify our relation filter. So we want the all posts with their author name is, for example, Jack. So here we can say is, and then inside it we put our criteria. So we want the name of the author to be Jack. Okay, let's save this and let's go back to our Insomnia, go to the post, and here let's send the request, and you can see the post with the ID of 2 is included in our result set. So let's go to the Prisma Studio, and here post with the ID 2, the author is number 3. So let's click on the user and you can see that the name of the user is Jack. Okay, the other relation filter on the many-to-one and one-to-one relationships is not. It's the opposite of the is relation filter. We can say is not. So this will return all the posts with the name of the author is not Jack. Okay, let's save this and go to our Insomnia, send the request, and you can see the post with the ID 1, 3, 4, and 5 are included in the result set, but the post with the ID of 2, this one, which is author name is Jack is not included in the result set. So these two relation filter, is and is not, only works with the many-to-one and one-to-one relationships, but the every, some, and known relation filters only works with the many-to-many and one-to-many relationship. Okay, so let's go back to our Insomnia, and here the last thing I should say in this section is that you can have more than one relation filters in a query. So here we can set two relation filter on the author model. So here we can say, for example, another relation filter here is, and then we can say, for example, email, and here inside it we can say, let's say email start with the letter S. So here we want to find our post with the author name is not Jack, but the email is start with the S. So let's go back to our Insomnia, send the request. You can see the post with the ID 3 and ID 4, 5 are included in our result set. And let's include the author inside the result set. So in order to do that, after the where object, you can just say include and set the author to true. So this will include the author object inside every post. So let's run our query again, and here you can see that the author is also included on every post. So here we can check the criteria. The name of the author of the post is not Jack. So none of them, the name is Jack, okay? But in all of them, the email of the author start with the S. So here this one start with the S, and again this one start with the S. So in this way we can have more than one relation filter on a query and also include the related model inside our query. Okay, now we can move to the next section, which is about selecting fields. If I go to the Insomnia, you can see that our query selects all the fields inside the post and also inside the author object. So what if we want only title in the post object? So in order to do that, we can use the select API. So if I go back to our VS Code here, so for now, let's remove the include API here, because using the select API and include API in the same time is a little tricky. I will come back to that in a second, but for now, let's see how we can just select the title of the post inside our query. So here we can use the select API, and then inside it we can define what field we want to be included in our query. So for example, we say title to true. Let's save this and go to Insomnia and send the request again, and this time you can see just the title of each post has been selected in our query. Okay, so now let's include the author of the post in our query and let's see what happens. So here we can say include, and inside it let's include the author and set it to true. Okay, as you can see, it will give us an error, and that's because we cannot use the select and include in the same level. So let's remove the include, and in order to include the author object inside our query, we can do that inside the select API. So here we can specify the author and set it to true. So let's save this and run the query again. You can see that it returns the title of the post and also whole author object with all its fields. We can also select specific fields inside the author object. So let's go back to our VS Code, and here instead of setting the whole author to true, we can set it to an object, and inside it we can say select, and here we can select specific fields of the author. For example, we can just select the name of the author and set it to true. So let's save this and go back to Insomnia. So let's send the request again, and here you can see we have selected the title of the post, and inside the author object we only have name. So yeah, in this way we can select specific fields in our query and also include other related object and also select specific fields inside the related object as well. Okay, now we are moving to the next subsection, which is about the aggregations functions. Prisma provides a set of built-in aggregation functions that we can use in our queries, such as count, sum, average, mean, and max. These functions can be applied to specific fields in your database table, allowing you to calculate counts, sums, averages, and other aggregate values based on the data stored in those fields. So before showing you how we can use these aggregate functions, let me go to the Prisma schema here and let's add a number field inside our post model, and here let's add a like num, which is number of likes of the post. So let's set it to int. We need to add a default value here, and for example set it to 0 for now. So now let me run a migration here to commit these changes into our database. So let's say npx prisma migrate dev, and then set the name of the migration to just adding like num. Okay, let's run it. Okay, and let's run the Prisma Studio again, and then go to our Prisma Studio, and here you can see inside the post table we have the like num. So let's quickly change the like number of each post to a random value. For example, let's say 25, 4, 16, 8, and 75. Okay, and save the changes. Okay, so now we can use the aggregation function in our queries. So let's create another route for our aggregation function. So let's add a aggregation route and then create our route.ts. Okay, so here we just need to export a async function, a get function, and then inside it can say const aggregations equals to wait prisma.post.aggregate, and then inside it we can specify which aggregation function we want to include in our query. So let's say we want to retrieve the sum of like nums of all posts. So here we can say underscore sum, and then inside it we can specify on which field we want to run our sum aggregation. So in this case we want to run the sum function on the like num. So we set the like num to true here. So let's save this and let's return a new response with the aggregations. Okay, and let's go to our Insomnia. I've already created a aggregation request here, which send a request to the /API/post/aggregation, the API route that we have just created. So let's send the GET request to it, and you can see it returns an object that has the underscore sum inside it, and then inside it we have the like num, and its value is the sum of the like num of all posts. Okay, we can also add another aggregation function inside our aggregate function. So here we can get the average number of the like num. So here we specify underscore average, and inside it we specify the field that we want to run the aggregation function on it. So let's set the like num to true and go to Insomnia, run the query again, and now we have a underscore avg object, which inside it the like num has a value of the average like num of all posts. Okay, so let's add another aggregation function, which is the count. And inside it, for example, let's specify the ID and set it to true. So this count API will count all the post object which their ID has a value. So let's save this and go to Insomnia, run the query again, and here you can see that we have 5 posts which their ID has a value. Actually, in this way, we count all the posts inside our post table. So we have 5 posts in our post table. The average like num is 25.6, and the sum of like num of all posts is 128. Okay, and now let's add the mean and max here. So here we can set the underscore max, and inside it we specify which fields we want to run the max function on, and let's specify the underscore mean as well, and also we want to run it on the like num. So let's go to Insomnia, run the query again. So here we can see that the maximum like num of a post is 75 and the minimum like num of a post is 4. And let's go to Prisma Studio, and you can see that the minimum like num is 4 and the maximum like num is 75. Okay, and these are the aggregation functions. We can also combine the aggregation function in group by function. So let me give you an example use case. So let's say that we want to retrieve the sum of like num of all posts of each user. So obviously here the user 4 has 2 posts, and we want to group the post of each user together and then calculate the sum of the like num of all posts of each user. So let's do it in action. Here, let's add another route for the group by. So here we can say group by, just group and slash route.ts. Okay, and here we just export a async function, a get function, and inside it we can say const group post equals to await prisma.post.group by, and here we provide an object, and in this object first we should specify based on which field we want to group our post. So here we specify the by API and set it to a list, and inside it we specify the fields that we want to group our post based on them. So here we want to group our post based on the author ID, and then we can specify our aggregation functions that we want to calculate on each group. So for example, let's say we want to calculate sum of the like num of each group. So here inside the sum object we set like num to true, and then we can also specify the average API. So here I say underscore avg, and inside it we set like num to true. Okay, so here actually we are saying that we want to group our post based on the author ID, and then we want to calculate the sum and average of like num of each group. Okay, and then return a new response with the group post. So let's save this and go to Insomnia. I've already created a group by request which send a get request to the /API/post/group, the API routes that we have just defined. Okay, and you can see user with the author ID of 3, sum of the like num is 4, and the average is 4, and that's because it only has a one post. So let's go back to our VS Code, and here let's add a underscore count to see how many posts a user have. So let's run it on the like num. Okay, let's run the query again, and here you can see the user 3 just has a one post, and here's the sum and average of the post. But the user of 4 has 2 posts. Okay, the sum of like num of its post is 24, and the average is 12. So yeah, in this way we can group the aggregate function based on a field in our model. So here we group the results based on the author ID field. Okay, and now we can move to the next subsection, which is about how we can sort the result of our query. Okay, in order to do that, let's create another route for sorting our results inside the post directory. So here we call it order and then route.ts. Okay, and inside it let's have a get function, and let's say const posts equals to await prisma.post.find many. Okay, and inside it now we can define our where object if we want to set a filter for this find many, but we just want to retrieve all the posts, so we don't need the where object, although we can have where object. So we can have a order by just like the where object, and here we can specify based on which field we want to sort our results. So here, for example, let's say we want to sort the result based on the like num. So here we specify like num, and instead of just setting it to true or false, we can specify the sort is ascending or descending. So let's go for ascending, and let's return a new response with the post and go to Insomnia. I've already created the order by request which send the get request to the /post/order. So let's run it, and here you can see the first post is the one with the lowest like num, and then on the next post the like num increase to the next, again 16, 25, and 75. So you can see that the result is sorted based on the like num in ascending way. So let's change it to descending. Okay, let's run the query again. So you can see that the first post now is the one with the like num of 75, the maximum one. And the second is 25, 16, 8, and 4. So yeah, in this way, we can sort our results based on a field, which we can set it to ascending or descending. Okay, now we can move to the next subsection, which is about pagination. Okay, I've already inserted some dummy data into our post table, and you can see there are about 63 posts inside our post table. So now we can use pagination when we want to retrieve this whole data from the post table. So I go to VS Code, and here inside the post API, I'm going to create another route for pagination. Okay, and inside it, first of all, we export the get function, and then inside it, just like before, we're going to say const posts equals to await prisma.post.find many. So this alone will return all the post records inside our post table, which was about 63 of them. So imagine that when we have thousands or even millions of posts inside our database, and with this command, you want to load millions of post records into your application, and guess what? Your server will be crashed. So in order to fix this problem, we should use pagination. So we break the whole data into pages, and every time we want to retrieve data from our database, we only retrieve one page, and we usually set the size of the page to 10 records. Okay, in Prisma, we can take advantage of pagination in two ways: offset-based pagination and also cursor-based pagination. Okay, in this section, we're going to implement the pagination in both ways. So first, we're going to go ahead with the offset pagination. In order to use offset pagination, first of all, we pass an object into the find many. And here, as you can remember, we can provide the where object, but we don't need where object in this use case. Beside the where object, we can provide two parameters here, skip and take. So skip determines how many records you want to skip, and takes determines that after skipping the records, how many records you want to retrieve from your database. So for example, let's say the size of the page is 10, and we want to retrieve the first page. We should set skip to 0 because we want to retrieve the first page. This means that we don't want to skip any data, okay? And the take, set it to 10. Okay, so in this way, we can retrieve the first page of our data from the post table. So let's return the response from this API, and let's save this and go to Insomnia. Okay, I've already created the pagination request, and here you can see that it will send a GET request to the API that we've just created. So let's send the request, and it retrieves the post till the ID of 10. So it returns the first 10 posts from our database. So let's say now we want to retrieve the second page. So to do that, we need to skip the first 10 posts and then take 10. We just skip 10 posts. Okay, so let's save this and send the request again, and you can see that now it retrieves from the ID 1 to ID of 20. If we want to retrieve the third page, we just need to skip the first 20. Okay, let's save this, send the request again. You can see that it retrieves from ID 21 to 30, which are on the third page. Okay, we can also let client to decide about the page size and also page number. So client inside the search params of this GET request can provide two values, page size and also page number. So in order to request the search params from this GET request, we need to have a request in the parameter of this GET request, and its type is the request. Okay, and here we can extract the search params from the request object. So I'm going to say const for now an object and set it to a new URL and pass the request.url. And here now we can extract the search params from the request.url. And here we first define two constants. The first one is the pgnum, which stands for the page number, and set it to search params.get, and then pass the pgnum as a string. So if the user provide a pgnum search params inside its request, it will catch by the search params and will be set to the pgnum. And if there is not a pgnum, just return a 0. And let's put a plus before the whole expression to convert it to a number. So now we have pgnum and its type is number. Okay, so we can copy that and do the same with the pg size, which is the page size. Okay, here we set the search params.get, and the name of the search param is pg size. So the client must provide a pgnum and also pg size as the search params inside its request. And here let's set default value of the page size to 10. Okay, and here we can set the skip to pgnum times pg size. For example, if the client wants the first page, it will pass the 0 to pgnum. Okay, so pgnum is now 0, and 0 times any number equals to 0. So our query doesn't skip any records. Okay, and then here set the check to just pg size. And for example, let's say user wants the second page, he or she passes 1 as page num. So 1 plus page size, whatever the page size is, for example, let's say it is 10, 1 times 10 equals 10, so it skips first 10 records and then takes the pg size record, which is 10 records. So it will return the second 10 records to the user. So let's save this and test it in Insomnia. Here inside the query tab here, I'm going to define a pgnum and set it to 0 for now, and add a pg size and set it to 10. So we set the page size to 10 and we want the first page. Okay, so let's send the request, and here as you can see it will return the id 1 to 10, which is the first page. And also we can set the page size to 5 if we want to, and you can see the result is from the id 1 to id of 5. And for example, let's say we want the third page, we pass 2 here, and you can see it will return 11 to 15 as the third page. Okay, so let's set the page size to 10 and we want the third page. Okay, it will return 21 to 30. So in this way we can implement the offset pagination in Prisma and let the client decide about the page size and also page number. Okay, the other way we can use pagination in Prisma is the cursor-based pagination. So here I'm going to comment this out, and here I'm going to say offset base, and here I'm going to say cursor based. So I just copy the previous get function, which is offset based pagination, and let's uncomment that. And here we don't want the skip, and instead we want something called cursor. Okay, and the cursor is the first post ID that we want our page starts from. Okay, for example, let's say the page size is 10 and we want 10 posts from the ID of 10. So we have to set the cursor to 10. So for example, inside the cursor we set ID to 10, and here we don't want the page num. Okay, instead we turn it to a cursor, and here again turn the search prompts to a cursor, so we can set it dynamically to our cursor. Okay, so user or client must provide two search prompts: the cursor, which is the start point of our page, and the page size, which how many records you want to include in your page. Okay, and let's put a comma here. So I think we're good to go. So let's go to Insomnia, and here I've already created a pagination underscore cursor request, and it will send a get request to the post/pagination, our API. But the only difference between the offset pagination is that it doesn't have a page num. It will have a cursor instead of the page num, and also the page size is the same. So if I send the request, we can see that we provide 12 as the cursor and page size of 10. So you can see here that the ID of our first post inside our result set starts from 12 and then 13, 14, and goes on to the 21, which is the last post in our page. So it will return 10 posts in our page, and the starting point of our page will be 12. So for example, let's set it to 25 and send the request. You can see that the ID of our first post is 25 and goes to the 34. Okay, so 25 to 34, which is 10 posts from our page. So yeah, in this way we can easily implement cursor-based pagination with Prisma. So we talked about offset-based and also cursor-based pagination. What is the difference between the offset and cursor-based? I think the most important difference between these two is that cursor-based is scalable, but the offset-based is not scalable, okay? For example, let's say you have 1 million records inside your post, and you want to skip the 5,000 records and then retrieve the next 10 records. In offset-based, your query must first traverse the 5,000 records and then reach to the next 10 records after that 5,000 records, which has a bad impact on your performance. But with the cursor-based pagination, it doesn't need to traverse the first 5,000 records. It will be just like a where filter that says that give me the records with the ID between 5,000 and 5,010, just like a filter query. But you should know that if you want to use cursor-based pagination, the data must be sorted on the cursors. So here we can see that we set our cursor on the ID of the records, and the IDs of the records are sorted in our database. But if you want to set the cursor on other fields, you first have to sort the results with the order by API and then put the cursor on the sorted field. So yeah, I think that's it for the pagination. We have implemented the both offset-based and also cursor-based. So now we can move on to the next section, which is about how we can insert some data into our database with Prisma clients. In this section, we're going to talk about how we can insert some new data into our database with create function. Okay, so let's say we want to add a user in our database. So first of all, let me create a separate route for creating a user in our database. So here inside the user directory, I want to create a directory called create, and then inside it, I'm going to create the route.ts file. Okay, then inside it, we need to export a async function, and this time the function is post, not get, okay? Because we want to add some data into our database, we use the post API. The get function is usually for retrieving data, okay? So here, I'm gonna say const user equals to await prisma.user.create. So this create function will insert a new entity in our database. Okay, so inside it, we're going to provide an object, and here inside the object, we have to specify a data object. And then inside it, we're going to specify the values of the fields of our new user. Okay, so for example, let's say its email is sakura@prisma.io and its name is Sakura Dev. Okay, and we can add other data like the role is going to be user. Okay, and now we can just return a new response and send the created user into the client. So let's save this and go to Insomnia. Here, as you can see, I have created a post API which send a request to the /API/user/create. So if I click on the send, you can see it returns a user object with the ID of 4. The email is sakura@prisma.io. Name is Sakura Dev, and the role of the user is set to user. And since the ID of the user model is set to auto increment, we don't need to provide the ID for the user. It will be created by the Postgres database automatically. Okay, and we can also create the post of the user on the fly in the same create function. So here inside the data object, we can say posts and set it to an object, and here we have two options. we can create some posts or we can connect some posts to the user. If the posts of the user are already inserted into our database, we can use the connect API. But if we want to create some posts of the user at the same time of creating the user, which means that the posts are not inserted in the database in advance, we can use the create API here. So here I'm going to use the create and then set it to a list here. And inside the list, we can specify the post of the user. So here, let's create the first one. Let's set the title of the post to a crash course of Prisma. Okay. And then we can set the published to true. And let's set the categories of the post to a object. And here we can create new category for this post, or we can connect the existing categories to this post. So let's connect some existing category to this post. Okay, so here let's set a list to connect API, and inside the list we can add a object for each category that we want to connect to this post. And inside each category object, we need to specify the ID of that category that we want to connect to this post. So for example, let's say we want to connect the category with the ID of 1, and since the relationship between the post and categories is many to many, we can connect multiple categories to this post. Okay, so let's say we want to connect the category with the ID of 2 to this post as well. So this is the case with the one-to-many relationship as well. With one-to-many relationships and many-to-many relationships, we can connect multiple items into our model. Okay, so here let's save this. And in order to test this, we need to delete the previous Sakura Dev user that we have created in our database, since the email can't be duplicated in our database. So let's just send the request to see what happens. And here we can see that there is an internal error, and that's because we are going to create a duplicate email in our database. So here you can see that the unique constraint failed on the field email. So in order to fix this, we can change the email of the new user to a new one, for example, Sakura2, or we can delete the previous one in our database. So here, let's change the email and let's save this and send the request again. And again, we got an internal server error. And here we have a unique constraint field on the field first name and role. So we have created this type of constraint on the user model. So we can delete this constraint and run a migration, but let's do it in a hard way. Let's remove the previous user from our database. So here inside the Prisma Studio, we delete the record. And here, if I send the request again, that will give us the response. So if I go back to Insomnia and refresh the page, you can see that the new user is inserted in our database with the new email. And if I go to the post table, I scroll down to the last post and you can see the post of the user, and its title is Crash Course of Prisma. And if I click on the user, you can see that the author of the post is Sakura Dev. Okay, and here in the post, you can see that the post of the new user is connected to two categories. You can see that it's the category with the ID of 1 and ID of 2, and their name is database and big data respectively. Okay, so in this way, we can create a user object, and on the fly, we can create their post. Okay, so let's go back to our VS Code, and here let's go to the create API. And here we have already seen that how we can create a related object and also connect a related object to the new entity. So the third option is connect or create. So let's remove the connect API from the categories and instead use a connect or create. And let's set it to an object. And here we can specify if a specific category with specific ID is already existed in our database, just connect it to this post. And if it's not existed, just create that category. For example, let's say if the category with the ID of 2 is existed in our database, just connect it to this post. And if it's not existed, just create a new one. and then connect it to this post. Okay, so here we can specify the where object, and inside it we can set the ID of the category that we want to check if it's existed or not. So here, let's say we want to check if the ID of 2 is existed in our database. And then here we specify the create API, and inside it we specify the name of the category that we want to create in case of it's not existed. So let's say the name is big data. Okay, so what we'll do this connect or create API is that first check if the category with the ID of 2 is existed. If that's the case, just connect it to the current post. And if the category with the ID of 2 is not existed, it will create it with the name of big data and then connect it to this post. So let's save this, and first let's delete the last user from our database. Okay, it will gives us an error, and that's because the user have a post, and first we need to delete that post from our database. And now we can save the changes to delete that post, and we can avoid this type of error with the cascading actions, which we are going to talk about in the next subsection. Okay, so for now let's go back to the Prisma and send a request, and here you can see the user with the ID of 10 has been created in our database. And let's refresh. The user with the ID of 10 is created, and let's go to the post of the user, and here you can see that the post with the crash course of Prisma is created. The user is the user number 10, Sakura Dev, and the categories is category with the ID of 2. So let's go back to our VS Code and change our scenario a little bit. So here we want to say check the category with the ID of 3. So if the category with the ID of 3 is existed, just connect it to our post. And if it's not existed, just create a new category. Let's create a ORM category and then connect it to the post. Okay, so again, we need to delete the last post and also delete the last user. Okay, so now we can go to Insomnia and send a request. The user with the ID of 11 is created in our database. Okay, here we can refresh. User number 11 is created. Go to post, and here you can see that the crash course of Prisma again is created. The user is the user number 11. Okay, and the category is the category with the ID 3, and the name of the category is ORM, which is new one that has been created by the connect or create API in our create function. Okay, so you have seen how we can create a nested object in our database with the create function. Okay, so let's talk about the cascading actions in Prisma. So we have seen that if we want to delete a user that has a post in our post table, the database gives us an error that says the user that we want to delete has a post in our database, and we need to delete that post before being able to delete the user. So if we want to automatically delete the post of a user when we are deleting that user, we can use cascading deletes in the Prisma. So in order to add this functionality, I go to the Prisma schema here and go to the post model. Here inside the author relation, we can define onDelete. Okay, so here we can specify when the author of the post is being deleted in the user table, what to do with its post. So setting the onDelete to cascade, just delete the post of the user when the user is being deleted. Okay, so let's save this, and in order to apply these changes in our database, we need to run a migration here. So let's open up a new terminal here and say npx prisma migrate dev and set the name of the migration to adding cascade. Okay, let's run it. Okay, so now we can go to Prisma and let's refresh. Let's delete the user, and you can see the user is deleted without any error. So let's go to the post, and here we shouldn't see the post of the deleted user, and you can see that the Prisma crash course is not there. So in this way we can delete the post of the user when the user itself is being deleted. So we can have specify other option in onDelete. For example, no action restrict, which is the default one. It prevents the user from deleting, which we have seen in the first place. Set default, for example, if we have defined a default value for the author ID, it will delete the user, but set the default value to the author ID. And the last option is set null. And when using this option on onDelete, the user can be deleted, but in the post of the user, the author ID field will be set to null. When using this option, we need to set the author ID or actual foreign key to optional, and also the author itself, and you can see the error is gone. So that's it with the cascading actions in Prisma. And one thing I should mention here is that we can use the cascading options on update API. So here we can specify on update, and here you can see we have the same option of the onDelete option. Okay, so let's remove that and let's set it to cascade. Okay, until this point, we have seen how we can create one instance of our model into our database. So here I go back to the create API of the user, and here I should mention that we can also create multiple user object or any instance of any other model in the same time. We can create multiple of them in the same time with the create many API. So let's comment out this create function. Okay, and here let's create a new one. Const users await prisma.user.create many. So here it's the same with the create API, and here we have to provide an object, and the difference here is that we set the data to a list of our user. Okay, so we set it to a list here, and inside the list we can define multiple user, just like what we have done in the create function. So let's close this off in order for you to see it better. So let's say we want to create two user here. So we specify two objects with the name and the users, and let's set the response to users here. Let's save this, go to Insomnia and send the request. You can see it returns an object with the number of users that have been inserted in our database. Okay, so let's refresh the post table here, and you can see new users have been inserted in our database. Okay, so let's go back to our VS Code, and here if we have a duplicate user, for example, let's say we are going to create 3 users, but one of them is duplicated. So let's go to Prisma Studio and delete last 2 users. Okay, and go to Insomnia, send the request, and it will give us a internal error. And the error is that we have failed on the unique constraint of the field email. So we can delete this duplicated user, or we can just after the data set the skip duplicates to true. So in this way, the create many function skips the duplicated users. So let's send our request again, and you can see 2 out of the 3 users have been inserted in our database. So let's refresh. You can see that the 2 users have been inserted, but the duplicated user has not been inserted in our database. Okay, so that's it for the create and create many function. And if I go to the seed.ts file inside the Prisma directory, now we can understand what happens in our seed file. We first create a list of user data that its type is set to a list of user create input, and then set it to a list of user data with their post, and then here we loop through that user data and then insert each user with the create function into our database. And before moving to the next section, I should mention here inside the create API, we can take the data of the new user from the client in the body of the post request. So in order to show you how we can do this, first we can define an interface for the body of the post request. For example, let's say interface body, and let's say we expect a name, which is going to be string, and also an email, which is going to be string as well. Okay, let me first close the previous example, and here inside the post request, we add a request object and set its type to request. Okay, and here we can access to the body of the request like this. So we say const body, and set its type to the body interface that we have just created, and let's set it to await request.json. So this request.json function resolves the body of the request. So here let's comment the create many function, and now we can say something like this: const user equals to await prisma.user.create, and then inside it you can specify an object and set the data object to body. Okay, and then return the user object. So let's save this and go to Insomnia. Here in the body of the request, let's set a JSON, and here we can specify the body of the request. So we have a name, okay, set it to, for example, test, and then we have a email and set it to test@test.com, a dummy user. Okay, so let's send the request, and you can see the user with the ID 24 has created in our database. The email of the user is test@test.com, the name is test, and the role is user because we have set the default value of the role to user in the Prisma schema file. Okay, so let's go to our user model inside the Prisma Studio. Let's refresh, and you can see the test@test.com with the name of test has been created in the user table. So in this way, we can take the user data from the client inside the body of the post request. So now we can move to the next section, which is about updating data in our database with Prisma client. So let's say that we want to update some data of a specific user in our database. So in order to do that, I'm going to create an update route. And then we have a dynamic route. We take the ID of the user and then create our route.ts file. Okay, so here I'm going to export a function, async function. This time we use the put API. Okay, so usually we use put API for updating data. So here, first of all, we need to access to the ID params. So here we can access to the params and set its type to an object that has params inside it, and these params contains an ID which is going to be a string. Okay, so now let's define the body of our put API function. So here we can say const updated user equals to await prisma.user.update function, and in this update function we provide an object, and inside it first we need to provide the where object, and here we specify a filter. We should tell the update function which user we want to update. So here let's say we want to update a user with the ID of params.id. Okay, so the ID of the user is a number, but the params.id is string. So let's convert it to a number. Okay, and here after the where object, we need to specify the data object. So in the data object, we provide the fields that we want to update with the new data. For example, let's say we want to update the name of the user and set it to, for example, just updated name. Okay, so let's save this and go to Insomnia to send the request to this API. So I've already created an update user API, a put request to the /API/user/update, and then we have to provide the ID of the user that we want to update. So let's go to Prisma Studio. Let's say we want to update the name of the user 24. So here we provide the 24 as the params to this API request and send the request. And here we're going to internal server error. If we are going to access to the params, we need to add the request. Okay, set its type to request. And also we need to add a response here with the updated user. So let's save this and send the request again. And you can see now the name of the user 24 is changed to the update name. Okay, so here inside the Prisma Studio, check it, and you can see the user number 24, the name updated to the update name. Okay, and here we can also get the new value of the name from the body of the put API. So first of all, let's define an interface for the body of the request. Okay, we expect a name inside it, set it to string, and here we can say const body, set its type to the body interface, and set it to await request.json. Okay, and now we can here set the name of the user to the body.name. And here inside the API, first inside the body, we provide an object with name to, for example, provided name. Okay, let's send the request, and here you can see the name of the user 24 is changed to the provided name. And here inside the Prisma Studio, if we check, the name is set to provided name. So in this way, we can update an entity with Prisma Client. The Prisma Client also provides us an update many function. With that, we can update multiple users in the same time. So here we can create another route for update many. Okay, and inside it create a route.ts file. Okay, here we export a async put function. Okay, and here inside it we can say const updated user, set it to await prisma.user.update many. Okay, provide an object inside it, provide a where, and we can say name contains e-letter inside it, and then we specify the data object. Inside it we set the name to the, for example, updated many. Okay, and then return a new response with the updated users. Okay, so if I go to the Prisma Studio, you can see that user 21, 23, and 24 has the E inside their name. Okay, so here inside the Insomnia, I've already created a updated many user and send a request to the update many user inside the user directory. So let's send the request. Well, it gives us a internal server, and that's because we created a really silly constraint on the user model, and is that first name and role cannot be duplicated. So here inside the update many function, let's set the role of the users to admin. So now the role of every user that contains a E inside its name will be updated to the admin. So let's send our request again, and you can see the 3 user updated, and let's go to Prisma Studio to check it. You can see the role of these 3 users have been updated to admin. So in this way, we can update multiple entities in the same time with the update many function. Okay, and now let me show you how we can upsert a user. So what is a upsert? A upsert first checks if the entity that we are going to update is existed in our database. So if that's the case, it will update the entity inside the database. And if it's not existed, it just simply create a new entity with the data we have provided. Okay, so let's copy this update dynamic route and let's paste it into the user, and let's rename it to Upsert. Okay, so we have a dynamic route /API/user/Upsert and then the ID of the user. So here inside the route handler, we can use the prisma.user.upsert. Okay, so we don't need the data object here. We have to provide a create object as well as the update object. So here, first of all, we provide the update object, and here we are saying that if a user with this ID is existed in our database, update its name with the user, for example, founder. And else, if such a user is not existed in our database, create a new user for us. And here we need to specify the name of the user, for example, new user, and set its email to newyuser@prisma.io. Okay, let's save this and go to Insomnia. Here we have created an Upsert user request, which send a put request to the Upsert API. So we are going to upsert the user with the ID 24. here inside our database, the user 24, the name is provided name. So this is the user 24 in our database. Okay, so let's send the request, and you can see that the name of the user now is changed to the user found. So if I refresh the Prisma Studio here, you can see the name of the user 24 has changed to the user founded. And let's change the ID of the user to 25, which is not existed in our database. So if I send the request, you can see the user with the ID 25 has been created in our database with the name of the new user and the email of new user at prisma.io. So if I go to Prisma Studio here, refresh, you can see user 25 has been created in our database. So this is the functionality of the Upsert function of Prisma Client. Okay, so now we are moving to the next section, which is about how we can delete the data from our database. Okay, so I go to VS Code, and here inside the user, let's copy the Upsert and let's rename it to delete. Okay, so I go inside this route and let's change the method of our API function to delete. Okay, let's remove this Upserted user, and here we can say, and we don't need the body. Okay, so here we say const user equals to wait prisma that user that delete, and then inside it we provide an object. Inside that object we have to provide the where object. So here we want to delete the user with the ID of params.id. Okay, and then return the user in the response of the API. So let's go to the Insomnia. Okay, here I have already created a delete user request, which send a delete request to the API that we have just created. So if I send the request, it will return the user with the ID 25. And if I go to the Prisma Studio, you can see the user 25 is on database, but if refresh the page, you can see the user has been deleted from our database. So in this easy way, we can delete a user or any other entity from our database. And we can also have delete many, just like the update many. It will delete multiple entities from our database based the filter that we provide inside the where object. So yeah, I think that's it for delete API, and we are ready to move to the last section of this tutorial, which is about transactions. So simply put, a transaction is a set of multiple CRUD operation that must be done as a single operation. If any of these operations fails, all the other operations must be rolled back. So always all the operation must be completed. If one of them fails, all the other completed operation must be rolled back to the state before the transaction started. Okay, so the typical example of a transaction is transferring money from one account to another account. So first we need to withdraw the amount of transfer from the first account and then deposit the amount of the transfer to the second account. So if the second operation, which is deposit the transfer amount to the second account, is failed for some reason, we need to roll back the first operation as well. Let's say we want to transfer 5 likes from the post number 1 to the post number 2. So this is a really dummy example, but you can see how we can implement a transaction like this in Prisma. So I go to VS Code, and inside the API/post, let's create a new route. I'm going to call it transaction, and then create the route handler for that. Okay, so inside it, we're going to export a post function, post, and then inside it, we need to define 2 update operations. So first, I'm going to say const withdraw update and set it to prisma.post.update. And here notice that we don't use the await before Prisma. We don't want to run it right away, okay? So here we just want to create a promise of this update operation. And then inside the update, we provide the where object, okay? We want to withdraw the likes from the post with the ID of 1, and then inside the data from the like num, we set it to an object and set the decrement to 5. So with the decrement API, we can decrease the value of a numerical field, okay? And then we need to create our second update. So here, let's copy that, say const, I'm gonna say deposit update, and update the post number 2, okay? And now we need to increment the like num to 5. So now we have created our first operation and second update operation. So here we can use the Prisma transaction API to run these two update operation as a single operation. So here we can say const result equals to await Prisma dot $ transaction, okay? And then here inside the transaction, we provide a list with our update operations. So first we need to run the withdraw update operation, and then we need to run the deposit update operation. And then let's return a response with the result object. So let's save this and go to Insomnia. Here, as you can see, I have created a transaction post API, which send a post request to the /post/transaction. Okay, let's send the request, and you can see the result contains two updated posts. The like num of the first post is set to 5, and then the like num of the second post is also set to 5. So we withdraw 5 likes from the first post and deposit the 5 likes to the second post. So if I go to Prisma Studio, of course I haven't updated Prisma here. So if I refresh, we can see now the like num of the first post is set to 5 and the second is set to 5 as well. So now let's set up a situation that one of these operations fails. So for example, let's say first we want to add a user with a duplicate email. So this will fail inside our database because we set a unique constraint on email fields in the user model. And then second operation is the update the like num of the post number 2. So I go back to VS Code and set the first operation to creating duplicate user, and then set prisma.user.create. Okay, let's remove them and set data to an object name equals to duplicated, and the email, let's copy the first user email, okay, paste it here. So our first operation is creating a duplicate user which will fail, and the second operation is to increment the number of likes num of post number 2. So let's save this and send the request to run the transaction. Okay, it will give us an internal error, so let's go back to VS Code to see what happens. And here you can see that the error says that we can't have a duplicate email inside the user table. So now let's go back to Prisma Studio and refresh the post table, and you can see the likes num of the post number 2 has not been changed. So let's go back to our VS Code and let's first run the deposit update so it will run without any error, and then run the creating duplicate user. So it will first update the like num of the post number 2 and then try to create a duplicate user. So let's save this, and here let's send the request, and again we have an internal error. So here, as you can see, again we have a unique constraint error on the email field. So let's go back to our post table and refresh the page, and you can see the likes num of the post number 2 has not been changed, even if the update operation is the first operation in our transaction. So you can see that the transaction runs multiple operations as a single operation. All of the operation will succeed it or fail together. And yeah, I think that's it for the transaction in Prisma. And also here is the endpoint of this tutorial. So if you like this tutorial, please hit the like button. And if you want more content like this, please subscribe to my channel. Have a nice time and stay tuned for my next tutorial.